Greetings of the day. Welcome to another session of Grade 9 Mathematics, Chapter 2 Polynomials. Dear students, in this session, we shall learn and understand what is factor theorem and its application by solving the questions given in NCERT exercise 2.4 from question number 1 to question number 3. Dear students, now let us understand what a factor theorem is all about. As you could see over here, I have given you the statement of factor theorem, which says that if p of x is a polynomial and a is any real number, then x minus a is a factor of p of x. If p of a is equal to 0. I can imagine the expressions on your face after reading out this statement. Let me put it in simpler words. Let us understand factor theorem with an example rather than as a statement. Let me take an example wherein I am going to check whether x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6. What am I going to check? Whether x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6. To check the same, what I shall do is something very similar to what we did in 0 of the polynomial. It's taking x plus 2 is equal to 0. Now when x plus 2 is equal to 0, the plus 2 goes to the other side. What do we get? X is equal to minus 2. So whichever is a polynomial which has to be checked whether it is a factor or not, that polynomial has to be taken as 0. So x plus 2 is equal to 0 and hence we get x is equal to minus 2. Then all that we have to do is what we have done very well previously in our previous sessions. Is first put up the question. What is the question? X cubed plus 3x squared plus 5x plus 6. So that becomes our p of x, that is polynomial of x. And in the next step, all that I'm going to do is replace the value of x by minus 2. So x is replaced by minus 2. Wherever there you find x, that has been replaced by minus 2. And in the third step, we find that p of minus 2 is equal to, what is minus 2 cube? That is minus 2 into minus 2 into minus 2. You get the answer as minus 8 plus this 3 as it is. Minus 2 square, minus 2 into minus 2 is plus 4. So I've written 4. Okay. Then we have plus 5 into minus 2. So plus 5 into minus 2 happens to be minus 10. And then plus 6 as it is. So when I solve it further, I get p of minus 2 is equal to minus 8 written as it is plus 3 4s are 12 minus 10 plus 6 as it was in the previous step. Now when I solve it all together, that is minus 8 plus 12 minus 10 plus 6, what am I left with? I'm getting the answer as 0. And if I'm getting the answer as 0, I can conclude that x plus 2 is a factor. See, dear kids, I did not conclude that minus 2 is a factor. Where did I get minus 2 from? I got minus 2 from x plus 2. Yeah. So when x plus 2 was taken as 0, that's when I got x is equal to minus 2. So if I'm getting the answer as 0, it means that x plus 2 from which I got minus 2. So x plus 2 is a factor of the given polynomial. This is all what the statement of the factor theorem also wanted to state. You can call x plus 2 as a factor when x plus 2 is equal to 0 and x is equal to minus 2 is put in place of the variable x in the given question. And if you get the answer as 0, then it is called a factor. What if the answer was not 0? Then x plus 2 will not have been considered as a factor of the given polynomial. Let us try to understand it further by solving a few more questions. We'll get into the NCERT exercise 2.4. Let us solve the first question of NCERT exercise 2.4, which is asking us to determine which of the following polynomials has x plus 1 as a factor. Okay, now if you remember, what we did is to decide whether x plus 1 is a factor or not, I have to take x plus 1 is equal to 0 and then solve it further. So let me take the first question. X cube plus x square plus x plus 1 is the question, and have to check for this question if x plus 1 is a factor or not. Okay, so I would write x plus 1 is equal to 0 to check whether it's a factor or not, and then solve this. What am I getting? X is equal to minus 1. So the plus 1 goes to the other side. It becomes x is equal to minus 1. So what would I do next? Simply put this value of x in the given question. So I'll write p of x is equal to x cube plus x square plus x plus 1. And in the next step, the value of x will be replaced by minus 1. So x is replaced by minus 1, as you could see over here. And when you solve it further, you realize that the answer is 0. So here p of minus 1 is 0. I repeat again, p of minus 1 is 0. So what does it conclude? That x plus 1 is a factor. Because where did we get minus 1 from? It is from this equation. Yes, this polynomial. So what would I say? That since p of minus 1 is 0 and minus 1 was obtained from this polynomial, I would say this polynomial, that is x plus 1, is a factor. Why is it a factor? Because the answer is 0. Let us get into the second question. The second question is x raised to the power 4 plus x cube plus x square plus x plus 1. And if you could recall, we have to check whether x plus 1 is a factor or not for all the questions. So let's start the same way. I'll write x. Let's say x plus 1 is equal to 0. Plus 1 goes to the other side. It becomes x is equal to minus 1. All that I will do is replace the value of x by minus 1. So wherever I get x, that is replaced by minus 1. Okay. Now, what I'm supposed to do next is simply solve. So minus 1 raised to the power 4 is minus 1 into minus 1 into minus 1 into minus 1. So it becomes positive 1, 1, 1, 1, 1. Yeah. Minus 1 cube, however, remains minus 1 because it is minus 1 into minus 1 into minus 1. So minus 1 multiplied few times. Minus 1 square, it becomes plus 1. And then plus minus, minus 1. And then I have plus 1 at the last. So when you solve this, what are you getting? You're getting that the value of p of minus 1 is equal to 1. Now see, here p of minus 1 is not equal to 0. What is not equal to 0? When I put the value of x by minus 1, that is p of minus 1 is not equal to 0. Hence, x plus 1 is not a factor. Yes, if you remember, in the previous cases, we were getting the answer as 0. Hence, we were saying that yes, it is a factor. But over here, we are not getting the answer as 0. See, here p of minus 1 is not equal to 0. Hence, x plus 1 is not a factor of the given polynomial. Let us get into the next question. The third question is x raised to the power 4 plus 3x cube plus 3x square plus x plus 1. Again, we have been asked to find whether x plus 1 is a factor or not. So x plus 1 is taken is equal to 0. That gives me plus 1 goes to the other side and it gives me x is equal to minus 1. So as I did in the previous sums, all that I shall be doing is replace the value of x by minus 1. So wherever you find x, that is replaced by minus 1. And when solved, in the last step, you'll find that p of minus 1 is equal to 1. It is not equal to 0. P of minus 1 is not equal to 0. So for this question, you will conclude that x plus 1 is not a factor. Since it is not equal to 0, it is not a factor of x raised to the power 4 plus 3x cubed plus 3x squared plus x plus 1. Let us get to the fourth question, which says x cubed minus x squared minus in the bracket 2 plus root 2 bracket close into x plus root 2. Now my dear students, I totally understand. By observing the question, you may find it difficult. We have brackets, we have roots, but my dear students, let us follow the same steps that we did in the last question. Let us take and find whether x plus 1 is a factor or not. So we'll begin the same way. We'll take x plus 1 is equal to 0. So that will give us x is equal to minus 1. And what shall we do next is put the value of minus 1 replacing x. So wherever you find x, you replace that with minus 1. So in the bracket, if you could see, 2 is written as it is, plus root 2 is written as it is, and I have an x. So that is replaced by minus 1 plus root 2. In the next step, p of minus 1 is equal to minus 1 cube is minus 1 itself. And then this minus sign comes over here. Minus 1 square is 1. So the 1 is written. And then minus, that is before the bracket. And then what I've done over here is minus 1 gets multiplied with 2 and minus 1 gets multiplied with root 2 also. So first, when minus 1 gets multiplied with 2, what do I have in the bracket? 2 into minus 1 is minus 2. Now, root 2 gets multiplied with minus 1. So I get minus root 2. And bracket close plus the last root 2 number that is present over here. Now, when you solve it further and open up the brackets, yeah, minus 1 is written as it is, this minus 1 also as it is. I open up the brackets now. So the bracket has negative sign, minus sign. So when I open up the bracket, this minus minus becomes plus 2. Minus minus becomes plus root 2 plus root 2. So now over here, if you solve it further, minus 1 is minus 2. Minus 2 plus 2 happens to be 0. Okay, so when I solve the first three integers, it's 0. Now what am I left with? Plus root 2 plus root 2. The answer is 2 root 2 plus root 2 is 2 root 2. And here also the answer is not 0. P of minus 1 is not 0, but instead it is 2 root 2. So what is the conclusion? That x plus 1, from where we got minus 1, yes. So x plus 1 is not a factor of x cubed minus x squared minus in the bracket 2 plus root 2 bracket close x plus root 2. So you must have observed over here, however the question may look like, the steps remains the same. So it is important for you to understand the concept rather than getting worried about the mathematical question. Now let us get into question number 2 of NCERT exercise 2.4, which is telling us use a factor theorem to determine whether g of x is a factor of p of x in each of the following cases. It's very similar to what we did in the last question number 1 with all the 4 questions that we did. Now, very similarly, it's given over here that P of x is equal to 2x cubed plus x squared minus 2x minus 1. And G of x is equal to x plus 1. We have been asked to check whether G of x, which is x plus 1, is a factor of P of x. It's very similar, or I would say exactly the same thing that we did in question number 1. The only difference is over there it was directly mentioned as x plus 1 is a factor or not. Check that. Over here it is mentioned as whether G of x is a factor of P of x. Okay, so it remains the same. In other words, we have to find whether x plus 1 is a factor or not. So we'll go the same way. We'll take x plus 1 is equal to 0. That gives you x is equal to minus 1. And then all that I have to do is replace the value of x by minus 1. So wherever there was x, that is replaced by minus 1. And as you can see over here, when we solve it further, we get the answer as 0. And when the answer is 0, I can conclude that x plus 1 is a factor. What is x plus 1? My G of x. So as mentioned in the question, to check whether G of x is a factor of P of x, I can here conclude that yes, G of x is a factor of P of x. Similarly, let us solve the second question, wherein P of x is equal to x cubed plus 3x squared plus 3x plus 2 and G of x is equal to x plus 2. I'll do the same way that I did last time around. Yes, to find whether the given polynomial is a factor of the another polynomial or not, all that I shall do is take x plus 2 is equal to 0. So when I took this, what am I getting is x is equal to minus 2. In the next step, what I shall do is, as I did in the previous sums, I'll replace the value of x by minus 2. So simply wherever you find x, replace that with minus 2. And when I solve it further, as you can see over here, the answer is minus 1. So here, P of minus 2 is not equal to 0. Since it is not equal to 0, x plus 2 is not a factor. That means G of x, which is x plus 2 actually. So G of x is not a factor of P of x. I believe this is clear to you all. Now, let us get into question number 3. For this question number 3 say that P of x is equal to x cubed minus 4x squared plus x plus 6. And we have got a G of x, which is x minus 3. And what is the question? To check whether G of x is a factor of P of x or not. So, to check whether it's a factor or not, what I shall do, I shall take it to be equal to 0. So, x minus 3 is equal to 0. Hence, x will be equal to 3. Minus 3 goes to the other side, it becomes 3. So, x is equal to 3. So, what I shall do next? Replace the value of x as 3. So, wherever I find x, I replace it with 3. And as you could see over here, when I solve it further, yes, what am I getting? The answer is 0. So when x is replaced by 3, the answer is 0. So when the answer is 0, what can we conclude? That x minus 3 is a factor. X minus 3 is a factor of this polynomial. In other words, x minus 3 is equal to what? G of x. So G of x is a factor of P of x. I hope this is clear to you all. If you have understood, question number 1 and question number 2 were very similar. It is just the difference was the way in which the question was framed. I hope this is clear to you now. How to find whether the given polynomial is a factor of another polynomial or not. Dear students, now let us use the same understanding that was used to solve question number 1 and 2 and solve question number 3. Here we have been asked to find the value of k, which is an unknown variable, if x minus 1 is a factor of p of x in each of the following cases. So here it is already mentioned that x minus 1 is a factor. Yeah. Here there is no nothing that we have to check. Here it is already given that x minus 1 is a factor. So we'll go the same way. X minus 1 is a factor. So x minus 1 is equal to 0. And hence x will be equal to 1. Replace the value of x by 1. Yes. So x square, that is 1 square plus 1 plus k. Now, here comes the most important step. Here, it is already mentioned that x minus 1 is a factor. So what would be p of 1 or p of x? It should be equal to 0 since it is a factor. So given that x minus is a factor, therefore p of 1 is equal to 0. So keep using that understanding, I'll put the 0 over here. So instead of p of 1, I'll write 0 is equal to 1 plus 1 plus k. The next step, 0 is equal to 1 plus 1 is 2. 2 plus k. What are we supposed to find? Find the value of k, right? So I'll bring the 2 onto the other side. So 0 plus 2 goes to the other side, becomes minus 2. So 0 minus 2 is minus 2. So what is the value of k? K is equal to minus 2. Okay. So the only catch in this solution was that since it is given that x minus 1 is a factor, all that we have to do is take p of x, or as it is mentioned p of 1 as 0. I hope this is clear to you. Very similar to what we did in question number 1 and question number 2. Let us understand it better by solving one more sum of the same question. That is question number 2, wherein it is given that p of x is equal to 2x squared plus kx plus root 2. And what is given? That x minus 1 is a factor. Okay. And we are supposed to find the value of this k. Let us solve it. So x minus 1 is a factor. So x minus 1 is equal to 0 and x is equal to minus 1. So find the value of x. Now replace the value of x by 1. Okay, as you could see over here, I replace the value of x by 1. Now, given that x minus 1 is a factor, what can I say? That p of 1 will be equal to 0. Yes, or p of x should be equal to 0. So my left hand side is 0. 0 is equal to, when you solve this, 1 square is 1, 2 ones are 2, plus k into 1 is k plus root 2. Now, what am I supposed to find? Find the value of k, right? So k is kept as it is. 2 goes to the other side, becomes minus 2. Even plus root 2 goes to the other side, becomes minus root 2. So what is the value of k? K is equal to minus 2 minus root 2. I hope you have understood this question. Now, let us get into the third question and the fourth one to have better practice of solving it. The third question is p of x is equal to kx squared minus root 2 x plus 1. My dear students, please don't worry about the type of question. Whether it has roots, whether it has brackets, all that you have to do is follow the simple steps. We'll begin with, as mentioned in the question, that x minus 1 is a factor. So, x minus 1 is equal to 0. Therefore, x will be equal to 1. And then the value of x will be replaced. Wherever you have x, you replace it by 1. And since it is already given in the question that x minus 1 is a factor, therefore, p of 1, that is the left hand side, will be taken as 0. So this is 0 is equal to 1 square is 1. 1 into k is k minus root 2 into 1 is root 2 plus 1. What are we supposed to find? Find the value of k, right? So k is written as it is. Minus root 2 goes to the other side. It becomes plus root 2. and plus 1 goes to the other side and we get minus 1. So what am I left with on the right hand side? Only k. Everything else is taken on the other side. So what is the value of k? K is equal to root 2 minus 1. Now, we'll get into the fourth question. I hope you are getting it clear how to find the value of k when a given polynomial is a factor. Coming to question number 4, wherein p of x is equal to kx squared minus 3x plus k. Okay, so over here also it has been mentioned that x minus 1 is a factor. X minus 1 is a factor. So we'll continue the same way. X minus 1 is equal to 0 and hence x is equal to 1 as we did in the previous sums. And then replace the value of x by 1. Okay. Now, so what do I have? P of 1 is equal to 1 square is 1. 1 into k is k minus 3 plus k. Okay. Now, as we did in the last questions or the previous ones, since x minus 1 is a factor, the left hand side, that is p of 1, will be equal to 0. So 0 is equal to k plus k, 2k minus 3. What are we supposed to find? The value of k, right? So first I'll bring minus 3 onto the other side, becomes plus 3. So 3 is equal to 2k. And to find the value of k, I bring 2 to the other side. So what do I get? 3 upon 2. So what is the value of k? K is equal to 3 upon 2. With this, we come to the end of today's session. My dear students, in this session, we have solved exercise 2.4, question number 1 to question number 3. Kindly practice it well in your notebook. This is all for today in this session. Take care of yourself until we meet next time with another session. Thank you.